Splines are another good way you can use to limit or refine distribution with Simple Scatter. To splines, just go to Add Component and search for Simple Scatter Spline. Once you find it, working with splines in Unreal Engine is a bit cumbersome, so the best way is to select spline, hit F, and then you actually have to deselect and reselect for the spline to appear, if it actually ever does. So let's try again. There we go. It's a bit faint, but once you find the first point, you're pretty much good to go. The splines are projected in 2D space along world Z axis, so the vertical position of the spline points doesn't really matter. Just keep in mind, currently as a known limitation, only the linear interpolation between spline points is supported. So if you want to do something curved, you will just have to add a few more points. So once I move the point, I can hold down Alt key to drag a few more and create some kind of shape. Now I can actually start tweaking the spline parameters. There's density distance fall off and there's scale distance fall off. So for example, if I increase the density distance fall off, you can see now that the density fall off is much further from the spline. The minimum value is where the fall off starts, the maximum value is where the fall off ends. So for example, if it's from 5,000 to 10,000 units, for the first 5,000 units the density is full, and then after 5,000 units it starts falling off to 0 up to 10,000 units. If I set it back to 0, the fall off curve changes basically the bias of the fall off. So the lower it is, the further it is out, the higher it is, the more it's concentrated next to the spline. Similar mechanism works for the scale distance fall off. So to illustrate it, I will actually set both min and max distance in this density distance fall off to the same value. And now I will set the max scale distance to the same value as well. So you can see now the scale of the instances falls off from the center outwards all the way to the edge of the spline, and again fall off curve affects if the fall off is more convex or more concave. This is for the fall off parameters, and actually these are the two most important parameters. First one defines if the spline is include or exclude, and the second one defines if the spline is open or closed. To actually illustrate this better, I'm gonna set these density parameters back to their defaults, and let's show you again. So this is the closed spline, this is the open spline, this is include, this is exclude, back to include, closed spline, again include, exclude. So for example, let's say we want to move our distribution. Let's actually select the entire component. If we can do that, we actually have to select the point first, then reselect the scatter, then select the component, and then we can move over the entire distribution. For example, here, let's actually select the point and make it a bit wider. Let's make the scale fall off towards the edges a little bit, and let's actually increase the density of our instances by decreasing the spacing. And now we have this isolated little forest here. Let's actually move the entire component here, and of course we can utilize multiple splines. So let's say for example that through this valley there will be some kind of road or path. For that, we will add another spline. And again, let's find where it is, which is always a bit tricky. There it is. There's the point. Let's get a point. And again, let's arrange the spline along some kind of path. like this. Let's call this exclude path. And let's actually make it an exclude spline. And let's maybe make the trees along the spline smaller. Not that far away, like this far away. And now we have a little path going through our forest, like this. So that's all there really is to splines. Just simple set of controls for the distance fall off and scale fall off, and controls if the spline is open or closed, and include or exclude. Just combining these few parameters with multiple splines can be very powerful in creating interesting custom distributions.